All right, so let's take a look at the odd number questions. So we take the derivative, so 12x plus 6, y dy dx is equal to 0, so 6y dy dx is equal to negative 12x. dy dx is then equal to negative 12x over 6y. So dy dx is equal to negative 2x over y. And then here we're going to use product rule, so second times the derivative of the first plus the first times the derivative of the second. And then I have 1 dy dx. So then I have x squared dy dx minus dy dx is equal to 2xy. So dy dx x squared minus 1 is equal to 2xy. So dy dx is equal to 2xy over x squared minus 1. Here again, product rule, so second times the derivative of the first plus the first times the derivative of the second. Minus 2 goes away, so then this is 1 over 7. So I have negative y minus dy dx is equal to 1 over 7. So dy dx, which is negative, is 1 over 7 plus y. So dy dx is equal to, oh, I messed this up. This should be x. I was like, why do I not have, this should be negative x. Is 1 over 7 plus y over negative x. And you could find a common denominator, but I'm not super concerned about it. And then here, I would have probably done this as x squared, y squared, because there's no addition in between there. There's multiplication. And then plus 3x is equal to y squared before I went and did the derivative. So y squared 2x plus x squared 2y dy dx plus 3 is equal to 2y dy dx. So then I get 2xy squared plus 2x squared y dy dx plus 3 is equal to 2y dy dx. So I have 2x squared y dy dx minus 2y dy dx is equal to negative 2xy squared minus 3. So then dy dx is equal to negative 2xy squared minus 3 over 2x squared y minus 2y. Okay, and then, let's see, so now, question 9 here. So I want to find the slope at any point on the curve. So I take the derivative of x, which is 1, plus, okay, so then the derivative of xy is the product rule, so that's y times the derivative of x plus x times the derivative of y, and then plus 4y dy dx is equal to 0, so dy dx x plus 4y is equal to negative 1 minus y, so dy dx is equal to negative 1 minus y over x plus 4y. And now here, equation of the tangent line, so dy dx at 2 comma 1 is equal to negative 1 minus 1 over 2 plus 4 times 1, which is negative 2 over 6, which is negative 1/3. So y minus 1 is equal to negative 1/3 x minus 2. And then here, slope is equal to, so I want to set my dy dx, so my negative 1 minus y over x plus 4y, and I want to set this equal to negative 1/3. So I cross multiply. All right, so now I'm going to cross multiply, so 3 negative 1 minus y, negative x plus 4y. So then I get negative 3 minus 3y is equal to negative x minus 4y. So then I get something. I get x is equal to, let's move the 3 over, and so I have a 3 minus y here. So now what I need to do is I need to take this and I need to plug this into the original equation to solve. So I have 3 minus y plus 3 minus y times y plus 2y squared is equal to 6. So 3 minus y plus 3y minus y squared plus 2y squared is equal to 6. So then we get y squared, and I get a 2y, and then I get a minus 3 because I have a 6 on this side and a positive 3, so I'm going to make one side equal to 0. So then I factor, I get y minus, so I want plus 3, and y minus 1 is equal to 0, so y is equal to negative 3 and 1. I already have my y is equal to 1 here with that coordinate point, so now I have y is equal to negative 3, so I'm going to plug that in here, so I get y is equal to 3 minus a negative 3, so x, just kidding. So x is equal to 6. So my other coordinate point is 6 comma negative 3. This whole idea of replugging back into the original equation, you guys are going to see a lot with free response questions. Okay, so 10a is just like 9a. 10b, tangents are vertical when the derivative is equal to 0 in the denominator, not in the numerator. So denominator equal to 0. Rate of change of the slope, that's a typo. The word the there. Rate of change of the slope is the second derivative. So 11a is the same thing as the other one. Determine whether the tangents to the curve at the x-intercepts are parallel. You want to find the equation of the tangent lines at both x-intercepts. So I want, if for an x-intercept, I want y to be equal to 0. Tangent of the curve is vertical. That's the denominator equal to 0. And then we've got a bunch of these that are at the end here. And I didn't do 11 or 10 because I wanted you guys to try those these are actual free response questions. So it's really good for you guys to try those on your own, just with a little bit of hints here. So find the derivative at negative 1, 1. Again, you have to use product rule in both of these situations. And then you will plug in that coordinate point. Again, here, product rule for the x squared, y squared, and also the xy here. Now, I will do this trig one, just so that we know. So again, tangent, this is a chain rule question. Outside is tangent, inside is a product rule. And then when you do the product rule and you take the derivative of y, you have to remember to write dy dx. Okay, so now let's do this one. So y squared times 1, and then x times 2y dy dx. And this is equal to the derivative of sine, and this is plus the derivative of sine, which is cosine of pi y, times the derivative of pi y, which is pi dy dx. Minus 4x is equal to 0. So y squared plus 2xy dy dx plus pi cosine of pi y dy dx minus 4x is equal to 0. So I have my 4x on the other side. I have my y squared on the other side, and this is going to be dy dx here, 2xy plus pi cosine of pi y here. So then dy dx is 4x minus y squared over 2xy plus pi cosine of pi y. And then I want that at this coordinate point. So I have dy dx, and I'm evaluating at 2, negative 3. So then this is 4 times 2 minus y squared. So that's negative 3 squared over 2 times negative 3 plus pi cosine of pi y. So negative 3 pi. So then I get 8 plus 9 over 4, negative 12 plus pi. Negative cosine of negative 3 pi is going to be negative 1. So then this is going to be 17 over negative 12 minus pi. Okay. All right, and that is it for the odd-numbered questions, give or take.